We're asked to evaluate the integral and determine if the integral is convergent or divergent. We have what's called an improper integral because the upper limit of integration is unbounded or approaches infinity. We begin by writing the improper integral as a limit. The given improper integral is equal to the limit as b approaches infinity of the integral from 4 to b of 5 natural log x divided by x dx. Notice we replaced the upper limit of integration with b, and then we took the limit as b approaches infinity of the integral from 4 to b. Next, to integrate, we'll have to perform u substitution. We will let u equal natural log x, and therefore du is equal to the derivative of natural log x times dx, which is 1 divided by x dx. And now we'll write the integral with respect to u. Let's first factor out the 5, and we can factor the 5 all the way out to the front of the limit, which gives us 5 times the limit as b approaches infinity of the integral. We need to be careful about the limits of integration from 4 to b. These are x values, not u values. To emphasize this, I'll write the lower limit as x equals 4 and the upper limit as x equals b. We've already factored out the 5, and therefore we're left with the integral of natural log x divided by x dx, which simplifies nicely to just the integral of u du. Natural log x is equal to u, and 1 divided by x dx is equal to du. Notice the antiderivative with respect to u is u squared divided by 2, or 1/2 u squared, which with respect to x would be 1/2 times the square of natural log x. This gives us 5 times the limit as b approaches infinity of the antiderivative with respect to x, again, is 1/2 times the square of natural log x. And because we have the antiderivative with respect to x, we do use the limits of integration from 4 to b. Next, we'll factor out the 1/2, and then determine big F of b minus big F of 4. This gives us 5/2 times the limit as b approaches infinity of, since we factored out the 1/2, big F of b is the square of natural log b, minus big F of 4 is the square of natural log 4. And now let's determine the limit as b approaches infinity. As b approaches infinity, natural log b approaches infinity slowly, but it still does approach infinity, and therefore the square of natural log b also approaches infinity. So if the square of natural log b approaches infinity, subtracting the square of natural log 4 doesn't really matter, and 5/2 times the value approaching infinity also doesn't matter, giving us a value that approaches positive infinity. So because positive infinity is not a real number, the limit doesn't exist, and we say the integral is divergent or diverges. When the limit does exist, and we have a real number for the value of the improper integral, we say the integral converges or is convergent. I hope you found this helpful.